What's the difference? Motional EMF versus transformer EMF, Faraday's law. Imagine you're holding a wire and moving it through a magnetic field. Suddenly, a voltage appears across the wire. That's a real-world example of motional electromotive force. Now picture a coil of wire with an alternating current running through it, creating a changing magnetic field around it. This changing field then induces a voltage in a nearby coil. That's a different kind of electromotive force. Both are linked to Faraday's law, but they happen in different ways. Motional electromotive force occurs when a conductor moves through a magnetic field that stays still. The movement causes the magnetic flux passing through the conductor to change because the conductor cuts across magnetic field lines. This change in flux generates a voltage along the conductor. Think of a metal rod sliding on rails in a magnetic field. As it moves, a voltage appears. This principle is what makes electric generators work, turning mechanical motion into electrical energy. Transformer electromotive force happens when the magnetic field around a stationary coil changes over time. Instead of moving the coil, you change the magnetic flux by varying the current in a nearby coil. This changing magnetic field then induces a voltage in the stationary coil. This is how transformers transfer electrical energy from one circuit to another, especially in power systems. They need alternating current because it creates a continuously changing magnetic field, which is essential for inducing voltage in the secondary coil. The main difference is how the magnetic flux changes. In motional electromotive force, the conductor moves through a static magnetic field, causing the flux to change. In transformer electromotive force, the magnetic flux itself changes because of a varying magnetic field, even if the conductor stays still. Both follow Faraday's law, which states that any change in magnetic flux through a circuit induces an electromotive force. Understanding this helps in designing electrical devices. Electric generators relying on motional electromotive force, where mechanical motion is key. Transformers depend on transformer electromotive force, which needs a changing magnetic field created by alternating current. So, whether you're turning a turbine or flipping a switch, these principles are at work, shaping how electrical energy is produced and distributed. Electromotive force is just the voltage generated by changing magnetic flux. Magnetic flux measures the amount of magnetic field passing through an area, and flux linkage considers how many turns of wire are involved. Recognizing the difference between these two types of electromotive force helps clarify how different electrical devices operate and why they need specific conditions to work efficiently.